So the equation we've got here, C of x equals 5/9 x minus 32, is the equation that converts a temperature from Fahrenheit into Celsius. So you take the Fahrenheit temperature, substitute it for x. The formula gives you the exact same temperature in Celsius. What we're going to do is we're going to find the inverse function. So first thing we're going to do is we're going to replace the C of x with y. So we're going to do y equals 5/9 x minus 32. And then to find an inverse, we switch the x and the y. So we're going to rewrite this as x equals 5/9 y minus 32. And now we're going to solve for x. So there's a couple of ways that we can do this. You may be thinking, since the 5/9 is in front of the parentheses, we should do distributive property. And doing distributive property is a great idea. We absolutely can do that, but we're going to do something a little sneakier. We're going to multiply both sides by 5/9. Rather than do distributive property, oh, not 5/9, what are you thinking, Taylor? We're going to multiply by 9/5. 5/9 would be silly. We're going to multiply by 9/5, the reciprocal, using the multiplication property of equality. Why is multiplying by the reciprocal going to help us? Well, it's because 9/5 times 5/9 is multiplying by the inverse, which is going to give us 1. So over on that side, we're going to have now just y minus 32. The 5/9 is going to go away. Over here on the other side, we have 9/5 x. So now we don't have to do distributive property. The thing we were going to have to distribute is now on the other side. Let's move this down a little bit so we got some room to work. Now we just have to add 32. So let's do that next. Let's add 32. That's the addition property of equality. If we did the distributive property instead, we would still get the same answer. We would just have to do 5/9 times y and 5/9 times 32. And that would add, number one, that would add in some extra work for us. And number two, we'd have to deal with fractions, and who wants to do that? So our equation we came up with is y equals 9/5 x plus 32. But the problem asked us to solve inverse c of x. That's what that little -1 means, is inverse c of x. So let's go ahead and write the notation that the problem asked us to do. So let's replace the y with that inverse notation, 9/5 x plus 32. There we go. Okay. Okay, what do x and inverse c of x represent in the context of the inverse function? So our original function that we had, x was the temperature in Fahrenheit and c of x was the temperature in Celsius, but we have now switched those. The inverse switches those two things. So now x is the temperature in Celsius and inverse c of x is the temperature in Fahrenheit. So now our equation does the opposite. It was Fahrenheit. Is that how you spell Fahrenheit? Maybe. So now our equation does the opposite. It was plug in Fahrenheit, get Celsius. The inverse does the opposite thing. Plug in Celsius, get Fahrenheit. So now we can answer this question. The average temperatures in July, for July, in degrees Fahrenheit. So we need to know what the average temperature was in July in degrees Celsius so that we can plug it in and get our average temperature in degrees Fahrenheit. So we need to go find whatever the average degree was in Celsius for July. And so I already looked this up beforehand. The average July temperature in Celsius. I don't know when you use Celsius or centigrade. Um, had a. Anybody know when do you use Celsius versus centigrade? Are those interchangeable? Minimum of 3 degrees and maximum of 15 degrees. All right. So 3 degrees Celsius and 15 degrees Celsius were the minimum average and maximum average in July. And I'm a American. I have no idea what that is. I don't know if that's hot or cold. So let's take our equation. Inverse C of x is 9/5 x plus 32. And we're going to solve this equation twice. Once with C substituted, once with 3 substituted for x, and once with 15 substituted for x. Okay, so inverse C of 3, that's going to tell us the average minimum temperature in Fahrenheit. And then we're going to go do it again. Inverse C of 15, that's going to tell us the average maximum temperature. Okay. All right, let's do a little bit of math here. So 9/5 times 3 is 27/5. So I'm going to use a calculator real quick to do 27 divided by 5. 27 divided by 5 is 5.4. Oh, duh. I could have done that without a calculator. Quit being lazy. Quit being lazy. So 37.4 degrees Fahrenheit is the minimum temperature, average minimum temperature. And then 9/5 times 15, one way you can do this without a calculator is 15 divided by 5 is 3. So that's 9 times 3. Or you could just use a calculator. That's 59 degrees Fahrenheit maximum. So our answer is the average July temp was between 37.4 degrees Fahrenheit and 59 degrees Fahrenheit. Now, if you're a Texas resident like me and you're thinking, that seems pretty nice for July, like frigid actually. We did not say this was in the southern United States. So some places in the world, some places that measure Celsius are cold in July. So between 37.4 and 59 degrees might make sense depending on which part of the world we're in. So minimum, maximum, 37.4 and 59. So we took our equation that converted from Fahrenheit to Celsius. We found the inverse of that function, which now does the opposite, converts Celsius to Fahrenheit. And then we plugged in 2 temperatures to actually use that equation to convert from Celsius to Fahrenheit so that us Americans that refuse to learn the Celsius system can still know whether or not we need a jacket when someone says it's 15 degrees Celsius outside.